Hello everyone, welcome to week 9 of this course. So we are now going back to prompting, and we will take a deep dive into what is prompting and various interesting aspects about that in this week. So that will be the topic that we will cover in this lecture. What is prompting? I'll talk a little bit on prompt engineering. There is a lot of resource available, but I'll just touch upon this briefly, and then we will talk about zero shot versus few shot prompting. Right, and then in the next lecture we will continue from here, discussing why this few shot prompting actually work. Right? So what is actually prompting? So what are we doing? So these are some examples, right? So this is a prompt. JDK is developed by, and say here a bird, pre-trained model bird, and that fills it by saying Oracle. Another prompt. This is a super long text. You give the text and then say TLDR. Too long to don't read, and you generate a summary using a BART model, again a pre-trained model. And ERNIE is another pre-trained model that is based on entities a bit. So birds can, it fills up fly. Right? So what is common here? You are seeing a pre-trained model. So whenever you are talking about prompting, you need to have a pre-trained model, otherwise you cannot prompt it directly. I mean fresh model, it will not do anything. So you need a pre-trained model. And you are typically not doing any training, you are not changing the parameters, you are using the same parameters, but what you are doing, you are giving some input to the model, and by its default behavior it will produce some output. Right? So there is no training happening. Right? So it makes some particular predictions by providing a textual prompt. Right? So this is all in text, you provide some input, and the way you provide in BERT, BART, say GPT may be different in the architecture, right? But the idea is same. You provide some input, let the model generate an output, right, without doing any training. Right. So the model already has been trained sufficiently so that you can understand the prompt. And typically, I mean, while this picture shows for models like BERT, BART, ERNIE, I mean, this prompting is more applied when the model is already instruction fine tuned and also has gone through phases like RLHF and so on. So what is a basic prompting? So what we do, we just typically append a textual string to the beginning of a sentence, right, and let the model complete it. So when a dog sees a squirrel, it will usually, so that is your input. So that will go in the prefix of the model, and now I can give it to any model, say GPT-2 or GPT-2 small or XL, and you see they will do the completions. श्री पीछे से नॉइज आ रहा है क्या?
कुछ बोल रहे हैं सर?
कुछ नॉइज आ रहा था, मतलब ऐसा कुछ है क्या कहीं माइक से या कहीं से? नहीं, हल्का सा कुछ नॉइज आवाज आता है, आपको नहीं आ रहा? ठीक है, मुझे कुछ आ रहा था. ठीक है, मैं इस स्लाइड से, हाँ. So what is a basic prompting, right? So what you do, so you have a language model that is already pre-trained, and you just append a textual string to the beginning of the sequence. Let the model complete it, right? That's what it is. So let's say I give this input string, textual string. When a dog sees a squirrel, it will usually, right, that's the input I have given as the prefix. And say if I'm putting it to GPT-2 small or GPT-2 XL, they will complete it. It will usually be afraid of anything unusual. As an exception, that's when a squirrel is usually afraid to bite. And GPT-2 XL, it will usually lick the squirrel. It will also touch its nose to the squirrel on the tail and nose if it can. I mean, they do some completions, right? GPT-2 models. Now, and this idea people have used for saying, okay, now I can talk about a template and make it do many different kind of tasks because of this behavior that given a prompt as input, it tries to complete. I can use that to do multiple tasks. So, for example, I want to do sentiment analysis. So, I have an input x, I want to do sentiment analysis. So, whether this is a positive sentence or negative sentence, this is a variable x, so I can put any sentence here. Right? I want to do a sentiment analysis. So, what I do, I create a template, right? Template so that I can feed any data from that. I don't have to manually do the prompting for every data point, but I can create a template. I say, okay, my template will be, I'll put the data, x is the data point, I'll put the data there, and then I'll put some text. Overall, it was, right? So, I love this movie, overall, it was. And G, whenever I say G, that's the completion that I need from the language model, right? And that becomes a template. So, then I can say prompting will be x prime. So, instead of putting input, I'll put like this. I love this movie, overall it was, and then G means what the model will complete. So, I will stop my input here, overall it was, that is my input to the model. I love this movie, overall it was, and the model will complete by saying whatever, like fantastic or so on. So, Z has to be filled by the pretend language model, and that is the idea of a prompt template. Now, you can have multiple types of template for the same task, right. So, and say, so suppose you are doing classification. Okay. So, let us say this is one example input. I love this movie for sentiment analysis. So, I can use a prompt like, okay, x is my input. So, I will fill x here, the movie is, and then I let the model fill G. So, G is what the model will fill, right. So, model can say, okay, great, fantastic, and so on. Say topics. So, suppose I have some topics. So, I can say input is he prompted the LM, right. So, let us say this is the input, and you can want to say, okay, x he prompted the LM, the text is about. So, topic text is about, and G will be the topic that the LM will fill. The text is about politics, sports, science. Intention, right. What is taxi fare to Denver? So, you are doing intention detection. So, you put that input here and say the question is about. Right. You see the variations that you are doing for the task to task. Right. So, this is very important thing, the prompt engineering, that how do you really prompt the model. So, how do you make the template? The question is about it about quantity, is it about city? So, you can put all the intentions as the valid possible answers. Okay. Something else like you want to do aspect based sentiment analysis. What is that? So, poor service but good food. That means for every aspect, like service is an aspect, food is an aspect, you want to know what is the sentiment of the user, right. So, you want to go more fine grained. So, you can say, okay, I will put the data x and then ask about individual aspect. So, what about service? Service is an aspect. So, what about service? So, the model can say bad, terrible, poor, right. Okay. Text pair. So, that means you are given a pair, you want to do natural language inference. So, you can, so here there was only a single data, now you have two data points x1, x2. So, you can create a template in terms of x1 and x2. You can say, okay, x1 and put a question mark, and G is what model will fill, comma x2, right. Now, you may similarly like tagging, Mike went to Paris is the data, and you want to say for Paris what is the name entity tag. So, x2. So, you can say, okay, x1, Mike went to Paris, Paris is a what kind of entity, G is something model will fill. So, now one thing you may think here, like this G is not the last thing in the template, right. I mean, if G is the last thing in the template, then I can simply give it as a prefix and let the model fill G, right. But how will I give this template? Because you have something after G, right. So, I need to provide everything to the model so that it fills G. So, you can see for these kind of templates, you have to use an encoder kind of model, where you use the mask language modeling. So, G is like a mask, and you predict what should be the word in that mask position, right. So, you have to use an encoder kind of model whenever your template is requiring model to fill at some position that is not the last word of the template, right. But here, for example, if you are doing summarization, typically you will do at the end, because you typically do not use encoder kind of models for summarization. Similarly, here translation. So, you say French, the input, English, and then let the model generate. So these are the templates, right? These are, I mean, some examples of templates, and there are like hundreds of templates people use. Now, even here, it may not be entirely clear how would you predict the answer. So one thing is, suppose I give a prompt. This is my prompt. I love this movie. Overall, it was G is what the model will say, right? So suppose the model will say fantastic, right? Now, how do I get my final answer? So you can take the output as it is. Like here, suppose fantastic is a valid output for you. You can take it as it is, right? But you can format it. You may select only the parts that are needed. Suppose you want only a numerical, you select numerical, or you may map the output to other action. Like here, suppose you are doing classification. So fantastic is okay, but fantastic does not give the class. Is it positive, negative, or neutral? So you need some other mapping that that can map some keywords to the class. That fantastic, whenever the model says fantastic, that's positive. Terrible, it's negative. You do some mapping separately. So you take the output and you do some processing and have some mapping to get the final output. So that may be required. I mean, because it is not specified that you have to only choose between certain outputs. So from a longer response, you select the information, like the LM may complete like this. I love this movie. Overall, it was a movie that was simply fantastic, right? So you were looking for a word, but it is giving more than a word. So you have to first extract what is relevant here, right? You can have some keywords that you've identified. If it is giving one of these keywords, yes, take it. If you are doing a numerical problem, you may just find I want to extract numbers, and yeah, I mean, if it is code, you just want to extract the codes. So you do some extraction. Now once you have extraction, you do the mapping, right? So that will be the process. So first it generates something. If you are doing a task like classification, which is not pure generation task, you first need to extract what is relevant. Then you have to map it to your labels, right? The fantastic should be mapped to positive. How do you do that? So you say, okay, interesting, fantastic, happy are positive, boring 1 star, etc., negative, and so on. So you have some mapping, so that you can convert this outputs to what you really desire, right? The classes, right? Now prompts can have many variations. So you can have a basic prompt where you just put something simple. I mean, input the sky age and let the model LLM produce an output, like here blue, right? So you have not given any instruction what has to be done. So the LLM will simply try to complete the sentence. That's all, right? That's the simplest basic prompt. But then you can give instruction that, okay, classify the text into negative or positive, and then you give the data. This is a great movie, the kind of thing that we were seeing. Yeah, so this is an instruction, right? So this would work when your model is instruction fine-tuned. Right? So typically your model should be instruction fine-tuned. So it can understand the instruction and will try to classify and say it says the text is positive, right? So this is what is the prompt. Instruction plus data becomes your prompt to the model, and this is the output of the LLM. Okay. So this is your instruction prompt. Now even in instruction prompt you can do modified. Say I don't want a full sentence, I just want a sentiment value. So you can say, okay, I give an output indicator, the text is this, what is the sentiment? So you say, okay, instruction, text, and output indicator sentiment. So the LLM will simply say it's positive. Right? So typically this is preferred if you want an output in a structured format, right? You just don't want a generation, but in a structured format output. You also give an indicator to the in the prompt. Okay. Now behind the scenes, every LLM will have some way of doing this prompting, I mean internally. So what is done, some messages are converted to token string. So you will have like llama model, you will have something for instruction, then you have something called system, right? So they are important roles: system, user, and assistant, right? So typically user is where the data is given, so user is for the data, and system is for giving the instruction, and assistant is your output. Language model is the assistant, so it will give you the output, right? Similarly here you can see system is where the instruction is given, and then you put the user, This movie is great. This is the input data, and assistant will give the response. Right now, this is something you are just appending. Right. So, in the code, what you will do, you will get the instruction, you will get the user, you will get and you will have some way of converting from there to this format, and once you have this format and response, it will start generating the output. Right. So, they will have some mapping. So, actually this book, so we'll also put it on our websites, hands-on large language models. So the chapter 6 has a very nice notebook on GitHub that lets you play with different prompt templates, right, and what happens inside a particular LM. Like they use phi3. This book, they use phi3 as the template example. So what happens here? So you have a beginning of sentence, BOS token, and the start of the prompt, you have a user, right, and the prompt is what is 1 plus 1, and you have an end. Then you may have for output, you have the assistant, and assistant gives the output, the answer to 1 plus 1 is 2, and you end. So this is what the LM is generating. Everything else is just the internal to the system, and you will just give this prompt and you get this output. Right? That's what will happen. But you can also print out what is the actual prompt. It can give you these entire strings. Okay. Now, how do you do prompt engineering? Right? I mean, that's a very common field, and so I'll just give a brief idea. So what is important is that you describe the task as clear as possible. Right? So it's very important when we want the output of LLMs to meet certain expectations. Right? So otherwise, it will anyway generate something. So suppose, for example, we are curious about climate change. So you can just put a simple prompt, tell me about climate change, and LLM will actually do something. It will generate a response that will address any aspect of climate change. I may not have that in mind. I may be interested in certain specific aspect of climate change, but it will give me some output, right? So suppose I want to be more specific. Say, okay, I want to say, okay, provide a detailed explanation of the causes and effects of climate change. This is what I am interested in, including the impact on global temperatures, weather patterns, and sea levels. So let's say I have a particular interest, right? So otherwise, it will, if I do this, it can do whatever, I mean, it feels like. But now it will focus by using these words in the prompt. It will focus on specific aspects, right? And you can say also discuss possible solutions and actions being taken to mitigate these effects. So now this is a very specific and detailed prompt, and you will get accordingly very structured output that will be structured around like what is the impact on cause and effect, what is the impact on global temperature, and so on, what are the solutions and what are the actions. So you will get all these in a structured manner. And typically, I mean, for doing any task that where you care about the output, it's better that you write a specific and detailed prompt, right? Now you may even vary this, say, okay, who is your target audience? So you say, okay, suppose you want to explain it to a 10-year-old child, right? So you can adjust saying, okay, explain the causes and effects of climate change to a 10-year-old child, talk about how it affects the weather, sea levels, and temperatures, mention some things people are doing to help, try to explain in simple terms and do not exceed certain number of words, right? So you don't want to make a like huge essay from there. So you see, you have modified the prompt to meet the audience for which it is intended, and you have also simplified the terms, and you are putting a length limit to cater to. So that's the idea. You try to keep modifying your prompt so that it matches the kind of output that you wanted. Right? Now, suppose you want to do some reasoning from language model, like you want to you wanted to solve some mathematics problem. You can just give a problem directly. It may solve it, right? But it may not solve in many cases. So one thing you can do is that, because maths require a detailed reasoning process, so if they directly attempt, they will make mistakes. So we can say we follow certain pattern, like you say first interpret the problem. So the mathematician carefully listens to your query and understands the intricate details of the mathematical challenge that you have presented. Then strategy formulation, that it is the most effective strategy tailored to the type of problem, algebra problem, geometry problem, calculus problem. And then you do a detailed calculation with precision expertise It performs the necessary calculations step by step, adhering to the mathematical principles, and then you review the solution also. So before providing the answer, it checks the calculations for accuracy and offers a concise explanation or rationale for the solution. So then given this, so this is how a mathematician does it. Now you are provided a math problem, please solve the problem. You give the problem, let it solve. So you have giving it a certain reasoning pattern to follow. Now whether it will follow it or not, but it will at least pay attention to all of these tokens that are in the prompt and use that to do things step by step. Right. Now there are other things you can do. For example, you can have multiple rounds of interaction. So first you say, okay, just solve the problem. So you are provided a math problem, please solve the problem. Now what will happen? It will generate the solution. So now it will say, okay, let it evaluate its own solution. So you ask the LLM to evaluate the correctness of the answer, and if necessary, you work out a new solution. So it's a new prompt, you will be provided with the math problem along with the solution, right? You may give it its own solution. So evaluate the correctness of the solution and identify any errors, and then work out on your own solution, right? So you give the problem and the solution it has presented and let it work out, right? So you can put this chain of prompts, right? So I mean, so how do you do better reasoning? We will have many other ways of doing that. So it will come later in one of the lectures. So we'll see about how do you do reasoning even better. But I mean, this is some simple strategy by which you can do. So this is one very nice complex prompt with many components. So suppose you want to do summarization. So you may actually want to instruct many things in the prompt, like what is a persona, like who are you? I mean, from what perspective are you summarizing? So you are an expert in large language models. You excel at breaking down complex papers into digestible summaries. That is, who are you, persona. Then what is the instruction? Summarize the key findings of the paper that you have provided. Then context. Your summary should extract the most crucial points that can help researchers quickly understand the most vital information of the paper. Then in what format do you want the output? That's very important. If you want a specific format, like create a bullet point summary that outlines the method and follow this up with a concise paragraph that encapsulates the main results. Then from whom it is intended, who is the audience? So for busy researchers that quickly need to grasp the newest trends in large language models, so they are the audience. And what should be the tone? So it should be professional and clear. Then you provide the data, right? And this will then give you the summary, right? So that's the idea. You may have to work on your prompt so that it serves the purpose for which you are using it, and you may use these guidelines for doing that. Okay. Now for doing real NLP tasks, right? I mean, what you can do prompts like just given the instruction, classify the text into neutral, negative, positive. So you give the text and let it produce the sentiment, right? Or you can give some examples. We saw in the case of GPT-3 that you give the instruction plus you give an example. That text, I think the food was all right and sentiment is neutral. So you give an example and let it say, okay, given a new text, what is the sentiment, right? So this is where, so this will all go into the prompt. So the instruction and example will all go in the prompt, and then this new data point, it will produce the output. You can give few short, that means you can give more than one example. So you have the same instruction, you have 3 examples, and then given a new input, you want to get the sentiment for that. So here by 3 examples, you could actually cover all the labels that were there. So now in the actual what happens behind the scenes, so you like in OpenAI models, you can add various roles. So you have system role where you are giving all these instruction and the examples. So you have system role where you are giving the instruction. You are an assistant that translates corporate jargon into plain English, right? And then even the example. So as an example user, you are giving that kind of input you will get from the user. New synergies will help drive top line growth. And what is the example assistant? Example output you will give. Things working well together will increase revenue, right? So this is a one short example that you have given. And then again, role as a user. So this is the user input. Now this is the example thing. This is the actual user input. This late pivot means we don't have time to boil the ocean for the client deliverable. Give the input and let the assistant finally give you the output. So now you will have assistant who will give you the output. Right. So So, so like here you are a helpful assistant and graded grammar correction. You provide 2 demos. You will be provided with the sentence in English. The task is to output the correct sentence. This is the input. There's many reasons to celebrate, and you correct it. There are many reasons to celebrate. Similarly, me and my friend goes to the gym. So my friend and I go to the gym, right? And you are getting a new input and you correct it. So what happens typically in few-shot learning, right? So we provide a pattern. So we are, by giving this few-shot examples, you are providing a pattern. This is the kind of input, you give an output, right? So map some input to some output, and the LLM is trying to follow this pattern, right, in making predictions. So if you have sufficient examples, it typically tends to learn from these examples and produce an output following these patterns. So you will have small number of examples, but some examples, and it tries to follow these patterns. Now there is a nice interesting aspect, like why does it actually work? See, we are not training the model, we are not fine-tuning the parameters. So even if we give a new task that it may not have been trained for, if you give some examples, how does it actually do for a new task? So why does it actually work? So we will take this question, like why does few-shot in context prompting, like few-shot prompting, why does it work, right? So we'll talk about this more in the next lecture. Now you can read more about this in this book. It has a nice chapter on this, foundations of large language models. There's a nice systematic survey on pre-train, prompt, and predict, and even the book hands-on large language models has a very nice chapter also at GitHub on prompting. Okay, so we will talk more about it in the next lecture. Thank you.